So first off, good morning for the delegates in West Coast, and good afternoon, I guess, for the people in Europe, and good evening if you're watching somewhere else. My name is Alex Kirkhope. I'm one of the founders and the CEO of Ondat. I'm also the co-chair of the CNCF Technical Advisory Group on storage. And Stephen made a reference there that, Ondat might sound like a new company name. You might have been following us or heard about us as Storage OS before, and I'll be talking about the rebrand and some of the strategic things we're seeing in the market that led to Ondat becoming our new name. So what is Ondat? We're a Kube native platform for running stateful applications anywhere and at scale. And the idea is that we enable developers to deploy and build any of their stateful applications and any of their services anywhere, whether they're on premises or in the cloud or in virtual environments, and on any of the Kubernetes, on the huge variety of Kubernetes platforms. So a little bit of an update about the company. Of course, we've just had a rebrand. We're growing really fast, and as part of our product-led growth, we're effectively rebranding to bring us in line with some of the big strategic changes that we're seeing in the market. So in the market, we're seeing this shift left to the developer, and I'll go into a little bit more detail as to what's driving that. But effectively, what we're seeing now is that developers are responsible for driving the data services and the storage environment. And we're effectively looking at moving beyond just deploying a storage system, but actually enabling developers to automate and build out their applications and provide some of the scale. And we're going to talk a little bit more about where we're seeing some of this growth. So the other thing I'd like to focus on is our customers. One of the key things I think that's changing here is to sort of underline this huge growth that we're seeing in the Kubernetes space and the cloud native space in general, is that we're moving beyond some of the more traditional verticals that have been adopting Kubernetes and containers in cloud native environments. So maybe a year ago we were very focused on verticals like financial services and service providers. But what we're actually seeing now is that the adoption is fairly ubiquitous, including in the education segment, retail, media, and even the defense space. So in order to capture this, and following on from our Series B, which we closed earlier this year, we've made a number of key hires. Richard Olver as our CRO, James Brown as our head of platforms, and we'll be speaking to them a little later. And we also are setting up a new advisory board, and the inaugural member is Cheryl Hung, who's the ex-head of ecosystem at the CNCF and now an engineering manager at Apple. As part of this growth, of course, we've been dramatically expanding the team. The team has grown by almost 100% this year as we engage more customers, as we build out engineering functions, and as we build out some of the new platforms and strategies that we're developing. So we talked a little bit about shifting left, but what does that really mean? This has been a trend that's been happening over a number of years, where developers, are moving to this new environment where they're building applications and deploying using containers. Depending on the surveys that, the surveys that are out there will quote lots of different numbers, but the reality is the bulk of all new applications are now being built in containers, and this makes applications portable and breaks that lock-in from, the server-centric infrastructure that we were maybe used to, say, a decade ago. And as developers do this, they're looking for ways to now automate their environments. The applications being portable means that an orchestrator like Kubernetes allows the developers to develop this superpower, if you wish, where they can specify their compute requirements, their networking requirements, or even their storage requirements now, and define what they need out of the infrastructure. And the orchestrator is then acting as a bit of an abstraction layer, automating the deployment, the scaling, the healing, the connectivity. And of course, Kubernetes has come a long way over the years, and there are lots of different distributions and managed services. It's fairly ubiquitous across all of the different providers. And what that now means is that developers are going beyond the initial deployments where maybe they were looking at front-end applications or stateless applications, and they're now looking to deploy stateful applications and build application-centric storage, right? So this is the difference with our cloud-native environment, where effectively we're looking at a scenario where the application is portable, the application can move into dynamic environments, and these environments can scale and grow on demand. And effectively, the storage needs to be able to cope with all of those different changes. But again, having the developers be able to declare and compose the data services that they need to build any stateful application, whether it's something as simple as needing a simple file system all the way to sophisticated databases or message queues, or even with newer projects, things and projects like Kube, even things like virtual machines. It allows them to build anything as a service, because now they have a simple template that they can use to deploy any type of stateful application. And this move to cloud native and the shift left is driving a strategic change, because we have this infrastructure dilemma, right, where the storage layer and those data services are the key to being performant and highly available and giving the application the scale it needs. But we're now adding all of the cloud native functionality to that too, right? Because developers are demanding that this is that the data services are self-service, and they have an on-off consumption model, and they have automation for deployment and operations. So we're kind of trying to figure out this dichotomy where in the past, a developer might rely on an infrastructure team to deploy and manage the performance with the availability of the storage. And now they're moving to a situation where they're actually responsible for making the decisions and responsible for defining storage as part of their application requirement. So what can we do to help? The Ondat platform is there to facilitate the move to stateful applications. We're deployed as using an operator in a completely platform agnostic way as a container to allow us to run on any platform, whether that's on premises or in the cloud. We virtualize the storage that's available on the different systems, and that can be physical disk or virtual disk or cloud disk, depending where you're running, and we aggregate that storage across all of the nodes. And we talked about how stateful applications need application-centric storage. Well, what we've done is we've created this concept of a data mesh, where effectively a volume or a data set that's used by a stateful application is now portable and can move with the application and is available on any node within a cluster, allowing developers to build and run any of those stateful applications or services through a declarative interface with Kubernetes. So a developer can now build their application and build their services on the data. We have the integrations and the drivers to compose and build that self-service environment. It's really important to note that, having standard services like a CSI API, for example, to build on those services is not enough. There's a difference between having a cloud native control plane and data plane versus, just tagging on a CSI driver to an existing traditional environment, because the rate of change and the rate of and portability and failover and complexity of these environments is radically different. And we also, of course, focus on, providing the data integrity to enable the developers to build these stateful applications in a mission critical way, just like they would do in their existing environments.
Alex,
the other key, yep.
Sorry, just a quick question. It's Enrico here. So up to this point, you are describing your former storage OS implementation, right? So there is nothing different than your traditional way to do things here.
So if you think of storage OS as the storage engine that we were building, think of Ondat in the sense of the car that we're taking to market, that we've built on that storage OS engine. And one of the key things that we're going to be taking forward from this Ondat platform is, and we're actually launching this today, so it's a scoop for all of you delegates, is that we're launching our SaaS platform that will allow Ondat to be used in a frictionless way by any developer who wants to be able to deploy within their environments. We're going to be talking about that in a little bit later as well, but happy to answer questions on that. In order to facilitate that frictionless environment for the developers, we've put a huge amount of effort into making sure that the developers can build anywhere, whether it's certification with key platforms like OpenShift or Rancher, or what we're actually seeing a lot of nowadays is Antos and EKS. And actually making sure that we can run in a seamless way and provide the same seamless declarative interface across any of the different platforms that the developer might be using. So we often see developers in cloud native worlds develop on their laptop, maybe deploy in the cloud for QA, and then maybe deploy on premise for some particular scale or some high performance item. So this ubiquity and platform agnostic solution that we've built with a really low overhead container that doesn't have any proprietary kernel dependencies or proprietary hardware dependencies means that the developer can get the benefit of this across every platform. And finally, of course, we talked about that dichotomy of maintaining the key items for the infrastructure, but also providing the self-service capabilities. So we talked a lot about self-service capabilities, but we also allow those developers to build at scale. And build at scale means a number of things. We're talking about, we're the leading high-performance cloud-native storage engine on the market, providing some of the lowest latency numbers available. And of course, as I'm sure you're all aware, low latency directly translates to transactions per second when it comes to things like databases or message queues. We protect the customer's data by replicating not just across nodes, but also across availability zones and failure domains to protect their data, even in the event of losing, a whole data center or losing an AZ. And we also encrypt the data both in flight and at rest, using keys that are managed and known only by the application. So effectively meaning that the customer can keep control of their entire end-to-end process, together with some unique integrations with some of the other KMSs in the environment.
Got a question from someone in the Twitter sphere. They have a question regarding Kubernetes storage and the plans around volume snapshot class capability.
Right. So snapshots is an interesting data services. That's something that's coming out shortly on our roadmap. One of the key things that we're looking at is building integrations with a number of different backup partners that allow us to effectively build those transparent systems. What we're finding is that snapshots as a general purpose tool is useful for developers, especially when they're developing in native test environments, etc., and mid-scale environments. But often the more complex databases or more complex systems tend to also need some sort of integration to perhaps, you know, automate database dumps or other services, you know, to directly integrate the database to the backup service. So that's what we're also going to be focusing on for some of the higher end enterprise customers too.
Okay, so it's on the roadmap.
Yeah.
Okay.
The other thing that allows us to build at scale is not just the services in the data plane, but also our cloud native control plane. So in the cloud native world, where lots of changes happen very frequently. So, you know, think CI/CD environments, for example, where we have customers that literally create and delete tens of thousands of volumes every single day. You need to have the cloud native capabilities to facilitate that change, and the amount of change that happens in a Kubernetes cluster, where, say, nodes come and go on a regular basis as part of, say, upgrades or dynamic scaling. So this is also another facility that allows our platform to enable developers to continue to build out at scale and actually deal with the high rate of change, as well as the individual performance for individual workloads.